it should be live in few seconds. Okay, so we are already live. Good evening, everyone. Welcome to this session on system design of YouTube. We will again be playing a role play of a mock interview. I'll be the interviewer and Ankit will be presenting the system design of YouTube as an interviewee. So just start with the brief introduction. So Ankit, assume this is your interview, and we are evaluating you for a senior software engineer position at Google, and this is a hypothetical situation. So I am starting the interview. So as an interviewer, now I will first put some icebreaker. So Ankit, yeah, briefly introduce about yourself, and then we can begin with the system design problem.
Sure. So, hey Tarun, thank you for the opportunity. Myself, Ankit, I am a multi-cloud certified. I have 355 certification in cloud and Kubernetes domain, and I'm a golden certificate holder. I have worked with many of the prestige organizations. I have worked with Amazon, I've worked with TCS, and today, I also have experience over Git, GitHub, Copilot, Python, Terraform, and the other DevOps tools. Yeah, that's it from my side.
Great, great. I have gone through your profile. You have an impressive background and a lot of very good certifications. So I see the AWS GenAI Solution Architect certification. And so, yes, tell me, what is the most useful certification so far you have done, which you are finding maximum value?
I think AWS Solution Architect Professor and AWS Gen AI Professor.
Awesome, awesome, great. So yeah, to quickly introduce myself, I am Tarun. I am having 20 plus years of experience in IT industry. I am also author of various books on microservices, cloud native architecture, as well as microservices architectural patterns. Have also been actively contributing to open source, mostly on Java domain, into Java EE, and into Eclipse Foundation's microprofile project. So now let me start the system design discussion with Ankit. So Ankit, please provide system design of YouTube. Assume you are the architect and you have to design a system similar to YouTube. Go ahead. How would you do that?
Sure. So do let me know. So first I'm sharing my screen. Please let me
Sure.
know once my screen is visible. Yeah. Is my screen visible?
Yes, your screen is visible.
Just a second. Let me this one also. Okay. So first of all, before discussing the YouTube architecture, before designing it as part of the solid principle and all the taking everything into consideration, we should understand what is YouTube. So YouTube is a platform where we can stream videos, we can watch videos, uh, uh, we can see live videos, we can publish our videos. So coming to the first and the foremost thing is the functional requirements of designing something like YouTube. So first of all, the functional requirement should be you should be able to upload and manage videos. You should be able to stream videos globally. You should be able to search videos and the respective channels also, whatever you want. Personalized recommendations should be there. Suppose if I am thinking about or if I'm watching something about travel or something, I should be getting recommendation related to that. Like, subscribe, comment, and share should be there. Subscribe to channel should be there. Notifications, playlists, and watch history should be there. And content moderation and copyright, which is the most important thing as of now. Copyright should be there. So these should be the functional requirement of the designing a platform like a YouTube. So I will be moving to the architecture also. I will be drawing some block diagrams and will be streaming the some of them.
Okay.
Before that, we
So,
should also,
yeah, now out of all the functional requirements, what are the main functional requirements you will be focusing? Because there are plenty of. So, choose, some of the important functional requirements which you will put in say MVP version of this product?
So for this MVP version, I will be choosing the most important one, which is video upload and processing. I will be drawing a pipeline for that. I will be using a video streaming flow pipeline also. So these two functional requirements will be the most important, which I will be describing in next few minutes as we move forward.
Sure, sounds good. No, uploading the video, processing the video, and enabling access of that video to global audience, with high
Yeah,
scalability. That would be good to start with. So yeah, you can focus on this particular one.
sure. So before drawing to that diagram also, or before drawing to that flow chart, we will be checking the non-functional requirements also, because they also serve as the important part. So for the non-functional requirement for a platform like YouTube, it should be highly available. Low latency should be there. High durability and scalability should be there. Fault tolerance should be there, because cap theorem somehow comes into this picture as of now. Security and cost efficiency should be there, like tier storage and CDN, because CDN will be there for content delivery network and for caching and everything what we'll be using in the platform. Low latency should be there.
Perfect.
So
Okay, so let me list down. So first is your functional requirement. Functional
yeah,
requirement is so number one, we decided to have upload of video and video processing. So I'm just sharing it to our audience.
sure.
So this is first use case. Second use case is about viewing the video. So the viewing should be very smooth experience, irrespective of the device. If someone is joining from, say, a low-end device, or if someone is joining from low resolution device, or in a low network environment, or in a very high speed network environment, for all kind of users, the experience should be best in class experience. Correct? So this is about the video viewing experience. So this should be best in class. Okay. Now reiterate the non-functional requirements.
So for non-functional requirement, availability, high availability, low latency, scalability, high durability, fault tolerant, global reach, and what I can say, cost efficiency should be there for
Yes.
tier storage and CDN.
So first thing is availability. We would like to have very good availability. So
Yeah,
I would say let's target 4 nines. 4 nines of availability. That means
99.9. Yeah,
99.99% of availability. The second important aspect is we
low
should target,
latency.
low latency is there. Let's target scalability. Scalability means that even if there are millions of viewers watching the same video, for all of them, the video experience should be good, right?
Right.
So site should be available, and the performance should be good for the site. So scalability, and let's say for scalability, we would like to have 300 million active users, and and maybe a video at a time could be served to have viewers like let's target 100 million viewers, right, for a video. So if we can say we may have up to 100 million concurrent viewers.
Okay.
So this is about scalability. Then what I would also want to know is, what do you mean by latency? Can you describe in detail?
So for low latency, what I means the startup time should be less than 2 seconds.
Okay, sure. So you can state it like this, that if I click on the play button for a video, the video should start playing
Start
immediately.
within less than 2 seconds. Within less than 2 seconds.
Yes. I think 2 seconds is too much of time. Let's keep it sub-second, 1 second or less, and there should not be any buffering. So if there is 1 hour long video, it should continuously play, and it should not have any buffering. Clear? Okay, what else?
Cost efficiency.
What do you mean by cost efficiency?
For like cost efficiency should be in terms of like what is the storage what we are using and the CDN networks what we are using, because caching will be also there for our YouTube videos.
Okay, on the device, say for example, on the client side, it should not download the entire video. So the device should not get overloaded. So this is also related to robustness or reliability, because if you are downloading a lot of content and memory is getting used, the application may become unstable. Because in Android, if a app is consuming too much of memory, it may kill it, right? So that could be an issue for low-end devices. So on client, it should consume lowest amount of memory, and it should also consume less network bandwidth. So it should not happen like a device which has a resolution of say HD, right? Generally, devices have very less resolution. So if suppose a device has say 800 to 1080 pixel of resolution, it should not download 4K quality videos, because that would be waste of bandwidth. So it should have less network cost, and also you should take care of how to store the videos efficiently, and have less cloud storage on the cloud, and with the minimum servers. Yeah, we should have an architecture where it is also profitable to run this particular business. Awesome. So this is no cost. So we talked about these are different parameters to take care of. Good. So this is good enough. I think we have covered. So you can go ahead.
Sure. So next will be the designing of that. Or before that, if you have any question like what will be the calculation, what will be using like something like estimation for this backup or envelope, we can discuss on that also. But what I will be thinking is I will be drawing the video streaming pipeline, video upload and processing pipeline first, and then video streaming flow. And we will be using a microservice architecture. So I will be drawing three architecture as of now, so that we have a simulation also and understand how the workflow works.
Okay.
Yeah.
Can we start with the REST API design and database design? What all data you will store at very high level, not at the column level, but at least at the table level, and roughly what kind of data you will be storing other than the video, and also about uh, what would be the APIs, right?
Okay.
So we
Sure.
will also like to expose this service to other clients. So you can give some APIs also. What would be
Sure.
the main APIs?
Sure. So let me first of all draw it for database. Is my screen visible?
Yes, your screen is visible.
Sure.
So I see you have written data store. Perfect.
Yeah.
So in the
First will
data
be
store, yeah,
metadata.
yeah,
Yeah. You are
perfect,
saying something.
perfect, perfect. So no worry, go ahead. Yeah.
Let me expand this.
Okay. So I see you have metadata storage. Okay.
Yeah,
Then you have users and channels database. Okay. And then you have playlist, comment, subscription. Okay.
yeah.
Perfect.
One
Uh,
more thing, I think search index should be there. For this, I will be using Elasticsearch.
okay. Perfect. So this you will use, I assume that your video will have description, title. So you
Yeah,
will
yeah.
use Elasticsearch to search through the videos. Okay.
Yes.
Uh, Perfect. So let's assume you have the metadata. Metadata would be title, description, maybe the count of the views, and maybe the date of upload, right? So there could be multiple metadata which could be related to copyright or the creation of the
Okay,
video.
yeah.
And then there should be something which is like transcript, right? Comments. So these you will store in the database. And roughly, let's assume that yeah, you will also have thumbnails as well. So roughly, let's assume for one video we have 10 MB of metadata,
Hmm.
correct? Which includes all the information about the video description, title, various other fields, could be tags, location, comments, etc. Right? So let's say 10 megabytes per video is the so you calculate the storage requirement? How much storage would you need for building this service?
So for like you told 10 MB will be metadata, but
Yes, yes.
and what will be the active users and everything, so that we can calculate it.
Yes. So for scalability, as I mentioned, we have 3 million active users,
Okay,
300 million active users.
okay, okay,
And let's assume that all the active users, they are uploading once a week a video, and the
okay,
video average size is around 500 MB.
okay. So 5 billion, you mentioned 500. So okay, 3 billion active monthly active users are there,
Yes,
and
yes. 300 million or zero point 0.3 billion. Yes. So yeah, how much data storage we would need?
approximately what I can say 1500 TB per day.
Okay. So you have around 500 MB per video. So
Yeah,
you would need 1500
yeah,
terabytes, right? Or
terabytes.
1.5 petabyte per day. Per day, you said?
Yeah,
Okay. Let's say we want to design this service to store videos for, let's say, next 10 years, correct? So 1.5 petabyte, and then for 10 years, let's say we can multiply with
okay,
400 for easy calculation for
okay.
per year. Let's say, yeah, so 10, 4,000,
Yeah,
correct? So that will come to somewhere around 6,000 petabytes,
petabytes. Yeah.
correct? So this will be the storage which we will be needing. But yes, you would also like to have reliability of storage. So what will you do for making the video reliable? Because if you upload a video and store it in some location, and if that hard drive crashes or there is some failure in that particular hardware device, how will you recover that video?
So for recovery, I will be storing all my videos in the S3 only. And since I will be using global edge locations on this point, and static assets should be there for my video, this will ensure reliability of the video.
Yeah, but if there is an outage in S3, how will you serve?
So failover, I will map my
Okay,
S3 to a failover, Route 53 failovers, so that once like any disaster or any region outage is there, the load should shift to another region immediately.
perfect. Okay,
Yeah.
sure. So at least 2 copies you should store, right?
Two
So
copies. A replica should be there in the other region
correct.
also.
So in that case, no, your storage size will become double. So we
Double.
have 6,000 petabytes, and then now if we are storing it twice, then it will be double,
12.
right?
Yeah. Yeah.
Correct. So yeah, go ahead with your design. So roughly, you have these much of a storage, but what would be the database size?
Okay. So database size. That if we are storing 12,000 or 6,000 per thing, so database size can be, if I'm not wrong,
Because
I
this
can.
is your
Yeah.
S3 size. This is
Mhm.
about what we calculated was for videos, right? But we can say that, okay, we have 300 million into every week. No, they will be uploading one video. So for 10 years, they will upload somewhere like 500 videos, right?
Mhm.
On average. So for these 500 videos, if we have 10 MB metadata per video, then this will be around this will come to around 1500 gigabytes, right? Or
1500, or I can say nearly around 2000 gigabyte will be sufficient for this
yeah,
10 years
2
of.
terabytes,
Yeah.
2000
Yeah. Yeah.
gigabytes or 2 terabytes would be the
Will be,
database,
yeah. Correct.
right?
Correct.
And how many rows will be there? So if you have 500 videos per user and 300 million, so there will be around yeah, in billions, right?
Billions. Yeah. Correct.
So few hundreds of billions of
200
videos
of
you will
billions
be
rows
having,
will be there. Yeah.
correct?
Yeah.
So what kind of database you will use for storing these so many billions of records? Will you use
Database.
relational database or NoSQL database, and why?
So database, I will be storing what I can say NoSQL only, and I will be basically storing everything in my data warehouse on this point.
Okay,
So for BigQuery and everything, data warehouse will be more than helpful in this situation.
okay. Why data warehouse?
For like as you mentioned, there will be billion of rows, and the like data will be stored and they will be uploading for 10 years. We need a BigQuery mechanism also, so that I can call my reports at any point of time for last 10 years also.
Okay. How about uh, using some document storage or something like Cassandra, or a key value storage like Redis?
So Cassandra will be used like for the metadata DB, as
Yes,
like I have
yes.
explained. Yeah,
So we are talking about the metadata only.
yeah.
So
So
you,
Cassandra will be used. For this,
yes.
Cassandra will be the most important one. Yeah.
Okay. What kind of consistency would you like to have?
Consistency in the terms like,
So you want asset guarantee, or you want eventual consistency for the metadata of the videos?
it should be eventual consistency I would go with.
Okay. You don't need strict consistency,
Yeah.
correct? Okay.
And for storing this also for 10 years, like in order to maintain the cost, we'll be using S3 Glacier Deep Archive, so that the storage is being optimized as per my use case, because this feature is important. This feature of is being offered by AWS if you are calling infrequently your video. So it is being pushed to S3 Glacier Deep Archive.
Okay.
Yeah.
Now, also let me know about what all processing you will have when a video is uploaded. What will be there in the pipeline?
So first of all, if you want, I can draw also, or
Sure.
we can, yeah. So let me draw it first. Suppose this is a user,
Yes.
and user uploads, because that is the first step for video process upload and processing pipeline.
Yes.
So the next step from the uploads, there
Okay.
will be resumable uploads also.
Okay. So what would be the chunk size?
chunk size I can calculate. I can use a multi-part upload on this chunk size on this point. So depending on the user, what he's uploading, it can be split it into multiple chunks and multi-parts. So it should be split it into MBs or the storage
Yes.
what he's uploading.
So if I upload a 500 MB video,
Hmm.
how many chunks you will create?
I can split it in 5 chunks of 100 MB.
Okay.
So the next will be validation and the virus scan.
Yes. So if I'm uploading using, say, my connection is 100 Mbps connection, right? So that means I will be able to upload this video in 8 seconds, 8 to 10 seconds.
Approximately 8 to 10
Correct,
seconds.
because it is
Yeah.
megabits per second. That's the
Yeah.
speed and my video. But yes, if there is some error in this chunk due to network, then I have to again retry this. So looks
Correct.
like no, this will be higher. Chunk size is little higher
Okay.
because it's taking 8 seconds to upload, and if it fails, then again it has to be retried. And while loading, if someone is viewing it on 10 Mbps connection, it will take around minute to load, or more than a minute to load this chunk. So you will have a buffering for more than 1 minute.
Okay. So yeah, I will be using Kafka also here.
So keep chunk size as 5 megabytes,
Okay.
5 MB.
Okay.
Perfect. Then you
So
have
Kafka will be there, will be acting as an event bus.
okay.
This tool is good, by the way. Paper.net. I saw your video recently on this.
Awesome. So yeah, I'll share the link to the video about this in the description. And Ankit has learned it in a day, in less than a day. I see he was seeing this comment. He commented today that he watched it, and I uploaded this video yesterday evening only. And today he is looking very comfortable with this tool. In few seconds, you have created almost like so many boxes and connections smoothly. Perfect. So yeah, you were struggling last time in the last video with draw.io.
Yeah.
So this is definitely giving you better output than draw.io. Awesome. Sure. So yeah, these are various processing pipelines. So how will you
So
ensure? So I see that you have used Kafka. So this will be asynchronous processing.
asynchronous processing, and it's used for like well distributed frameworks. Kafka and is the most suitable one. On this
So
one.
what's the benefit of here using this uh, queue mechanism or asynchronous processing for this? What if we could have done it in synchronous manner? That means no, we do these sequentially one after the other.
So for this asynchronous mechanism, the queue mechanism what we are using, it should be something. It will help as a like what I can say. If some queue is being not being distributed or DFQ process is coming into this, so asynchronous will be the which might be like having more advantage over the synchronous one rather than using a single pipeline or single queue of the events one by one.
Yeah, with single queue. So these are long running processes.
Yeah.
So here background jobs will be there, but we don't want to kind of block other activities. So if you have something like Kafka, we can run multiple jobs at the same time. So you don't have to kind of wait For the other jobs, they can be run without any dependencies. And if some jobs fails, or if there is any corruption in between, you can retry this. So you
Yeah.
make this pipeline more reliable, you make it more scalable, and you make it even faster with respect to better performance by running this in concurrent mode. So that's kind of advantage of using Kafka event bus.
Just think for this arrow, it's going in reverse direction.
Yes. Yes, I also found this arrow tool is little bit tricky.
Yeah,
Try
it
to
is.
put
Yeah,
this inside the box, then arrow will automatically take the nearest connector.
nearest connector. Yeah, that's
Now if you are trying to draw an arrow, you have now normal cursor selected, so you have to switch to an arrow. Yeah.
yeah. Because this is joining 2 points, and it is joining only 2 points when you are defining the 2 points.
Yes. But
Let me reverse this arrow. This is wrong. So let me start this animation. So this is how the and after that these the all the like transcoding thumbnails and will be connected to a distributed object storage, which will be original and transported videos will be there. So this will be our workflow, or this will be our simulation.
okay, great. Great. So you have the user uploading videos, and then it's doing a lot of other tasks.
Yeah.
Okay. So you have basically your arrow, the user when upload, it will just create a Kafka event video
Kafka
uploaded.
event, Kafka event
So
video
you
upload,
have
and once the user upload, it will follow chunk upload and validation will be there.
yes,
And once the
and the
chunk, yeah,
virus and validation scan should be also taken, should be a consumer of the queue, right? That arrow which is from the chunk upload to the validation and virus scan, that arrow you should make it to from originating from the Kafka rather than
okay,
from the container.
okay, okay. Let me stop this.
Yeah, you can. Yeah, so this is the report they have given.
Let me delete this connection. Okay. So
Perfect.
let me start this.
Sure. So yeah, the arrow we can always
Arrow can be
ignore.
modified,
Yeah,
like,
we
but
can
the
ignore
simulation is good
because
in this. At least
we
it's showing
have all
the
the
complete load. Yeah.
yes, because so all the processors or worker threads, worker nodes will be writing to the queue and reading to the queue. So it will be
Yeah.
all bidirectional arrows, correct? Because they will be publishing an event when they are complete, or when they have picked up some job, and there could be dead letter queues, there could be other status related updates which they might do. And if some so let's say you are doing a virus scan for one video. In the middle, the instance which is doing the virus scan crashes out. So how do you ensure that the virus scan happens for all the videos and no video is skipped?
For this, I will be using something like, if virus scan is my priority, I might be using some cron job, anything which might scan everything for within the time period what I specified. And if that report I does not get, I will ensure the scan is being done multiple times over, so that it's not being skipped. Like, there is no process, or there is no while scanning properties being skipped. Obviously.
Yeah, but if you do the virus scan multiple times, that will be expensive, right? So
Okay.
how can you ensure that the scan is done only once and no video is getting skipped?
I'm unsure about this. Yeah.
So you could have a status table, and you
Okay.
can have definitely multiple instances of running the uh, scan, and you may have in the status table details about what videos have already been scanned. So whenever some new instance picks up the virus scan, it can check whether the video has been processed by virus scan. If not, then only it picks up. And if it has completed, it will update back the table. So this way you
It
will
will,
ensure
yeah. Okay. It will update the records of the table.
yes, yes.
Yeah.
But yeah, you can have a background job which can scan the table, and whatever videos have not been scanned, it can be allocated to the
Hello. Yeah.
instances which
Yeah.
are responsible for doing the scan. Correct. So so this is about your video processing. How will you deal with now? So your video processing pipeline is done. How will you store this video to S3? When are you doing the storage to S3?
So after this step, I will be using a distributed object storage. So let me draw that also.
Sure. So click on the container text within this.
Yeah.
You
It will
can
be
modify
showing
the
the, yeah.
container name or component name. When you click on that container name, here you will put the distributed storage. So some glitches there, it got
There's some
deleted.
glitches there as of now, yeah.
Deleted.
So that's why I'm, yeah, just using
Yes.
container here only. And
Yes.
under that, I'm just adding.
Yes. Because
No worries, but it will be used here only on this point.
yeah.
Once thumbnail generation is being done, and it should be mapped to the distributed and object storage.
Okay. So now what is transcoding? You mentioned
Transcoding will be that one fit, like 144, like someone is using 104, 1080, or like 144p
correct.
or 8K. Yeah, so this will be the transfer.
So how many devices you will support?
Up to 8K, I will support.
Okay.
Yeah.
And what would be the lowest resolution you will be supporting?
144p.
Okay. So how many total formats will you store?
For this, I can roughly calculate is 7 to 8.
Sure. Okay. Yeah, that could be higher, maybe
Okay,
4, right? So you can have 8K, 4K, 1K,
4K, 2K,
right?
1K. Yeah.
Correct.
Yeah.
And you may have maybe low resolution, low end devices, and then something for intermediate end. So yeah, 6. I try to
6 to
kind of
7.
get 4 or 6 because more copies you will do, there will be more processing as well as storage also, because then now our storage will further increase 6 times. Correct. Now,
Yeah.
how will you ensure that some videos know which are very commonly used, they get very fast access to global audience? So where will you store these no videos, in which regions? Or
Regions and yeah, yeah,
you
yeah.
will
Sorry.
because we want to offer very high performance, so if someone clicks on load or play button, it should within a second load, right? And if suppose all the videos are stored in say US and I'm viewing from India, that time network latency itself will become 1 second. So how would you ensure that no audience in India also view the video very at for very fast rate, and same for people in any location?
So for this CDM will be used and it will be like delivering me low latency delivery on this point because CDM is the most important mechanism and I will use global edge locations with global accelerator on this point.
Okay, awesome. Uh, so you will have the CDN and with the edge
Global
servers
edge, yeah, global edge locations. Yeah.
correct. Uh, then so we have covered about the chunking and
And
about the
also for like as of now, like there are some trends going on in the YouTube also. So for this, I will be using caching with Redis cluster, which will be sharing with like hot metadata, trending videos, user sessions, and recommendations over
okay.
my feed. Yeah.
Okay. Now, how will you define decide that no? Suppose I am watching the video. I am watching from iPhone, maybe latest iPhone, iPhone 17.
Mhm.
How will you decide that which resolution of the video I should be getting in my device?
So for this, I can use like uh, if video metadata service will be there, which might be helping on this one.
Yeah, but can we detect the device of the users?
I am unsure about this.
Okay. So yeah, there are multiple ways in which you can detect the device. One way, which is very straightforward way, is when a request is sent, there in the header, the client type is sent. So
Client,
what
okay.
browser and
Yeah.
what operating system I am using to send the request, even the device details will also be available. So that's one way of detecting. Other way is you can detect from the footprint or this.
So from this client tag only I can like suppose if someone is uploading from the gaming console also I can like
Yes,
verify it from the client header. Web browser also I can
yes,
be verifying.
yes. Even other easy way is when I'm accessing my this site through my iPhone app. So as I'm using iOS app, it will be like iOS device,
iOS
and
device.
if you have Android device, then definitely the request will come from Android app. Right? Same will apply
And
for TVs
yeah,
and browsers also. Operating system also you can detect.
device can be smart TV also because nowadays smart TV also browse the YouTube. So from this client header only I can identify there's a smart TV.
Yes, yes. And for each of the device type, you should have a mapping of what resolution you should send.
Yeah.
Correct? Now, the other thing is how would you detect the network speed of my device? Can server detect the network speed of client?
So I think load balancer will be helping on this point to detect that.
No, on the client
Because
side. How will it
okay,
help?
on the client side, I'm not aware like how
Sure.
it will be detected.
So you can check that how much chunks are already loaded
Chunks
on
are
the,
okay. Chunks are
so
loaded and how it's the speed of the chunk loading and
yes,
how the
yes,
multi-part. Yeah. Yeah.
correct. So for each of the chunk when it's uploaded, you will get the confirmation from the client. So you can see what is the time lag, and from that you can decide the network speed. And based on the device type and network speed, you will have to identify what chunk to send, right? So have you heard about adaptive bit?
Adaptive byte trace streaming.
Yes,
Yeah.
yes, yes.
It
So
is useful in this resumable uploads and any the process like this. Yeah.
correct, correct. So how does it work?
So adaptive byte streaming like is helpful when there is like when we are uploading in chunks or multi-part upload is being happening. So it helps me in resumable uploads and it ensures that none of the part of my video is being lost while I'm uploading when there is a network disturbance or any of the mechanism is being uploaded.
Yes, but how does it work? Uh, so if suppose I'm traveling, I'm working on a device, right? Say iPhone. I'm traveling with my iPhone, and I'm maybe driving. So I go from say financial district to some village location, and now my during this watching of the video, my network speed changes. So how will you deal with that situation? Like when I'm on the go, my speed is say decreasing over time, so I will not get the good experience because you have detected higher end device and you have detected high network speed. So you have to continuously monitor my speed, and then based on all these changes you have to update the chunks.
So, like what in the adaptive byte streaming occurs, like if you are like if there is a network disturbance or network decrease or increase is there, it generally fetches the client video metadata and it downloads the manifest file and chooses the best format as per your network what is being
Yes,
at present at your device and dynamically switches the quality, the internet speed goes up and goes down.
yes, correct. So you would be giving me different
This, yeah, correct.
resolutions,
This, yeah,
but
this
chunks,
feature,
yeah.
yeah, yeah.
So the other problem is when I'm downloading the chunks, some chunks may get out of sequence, correct? So how will you ensure that all the chunks are in the same sequence?
So what for this I will be like stored rather than storing the video in a single file, I will break that file into multiple parts and store them in multiple resolution and byte rates, which will be
Yes,
helping in this.
yes. But then how will you ensure that there is what kind of uh, video file I have downloaded and they are playing in the right sequence?
Okay, for this I am unsure on this point because adaptive byte rate training
Yeah,
this is a
because with
yeah
download, when I'm downloading different chunks, I may receive it in different order,
order also yeah.
correct? So the way you can deal with this is there's something called MKV file, or it's similar to playlist, right? So
Please,
when
okay.
you have a playlist, you have the sequence that this is my first video, this is time from this time, start time to end time. Then for each of the chunk, you will have a playlist. So the server should generate a playlist and first share that playlist to the client device. It will be a text format playlist file, and then all the chunks will appear and they will be played by the video player. Video player should be able to understand the playlist file, MKV file, and should start playing the chunks in the same order, correct? So
Yeah.
this way you may kind of ensure that video is played and it's not jumbled. Uh, what if some chunks get corrupted? How will you detect that?
Some chunks get detect uh, so chunks get corrupted. Also, there should be an end-to-end file which should be available. And if something is missing, I would go on this point. But chunks should not be decrypted as of now or corrupted when there is adaptive bitrate streaming. So,
No, in the network, there could be
mhm.
some error. Some bits may get changed, right, while they transfer, because it's all no over electronic or optical cables. So there can be disturbances or noise, right? So which you would understand better as an electronics engineer, that noise is always possible, right, during the transmission. So maybe something, some blurriness or some distortion either in the video or on the audio may happen. So how will you ensure that there's no distortion?
Hash validation can be used on this point.
Yeah, checksum, you can use some
Checksum or
checksum,
hash
checksum
validation or
to,
retry download from CDN,
yes.
which might be
So
helpful on
if
this point.
some corruption is there, then you may try to reload the same chunk. You request the same chunk again from the server. So this is one strategy which you can
And
use.
one more thing can be used, because if there is a chunk corruption, we already discussed about the failover one. So fall fetch from another CDN network can be helpful on this point.
Okay,
Yeah.
but those other CDN may also degrade the performance, and it may again give the corrupted video, right? So there's no guarantee, that can also happen. So switching the CDN may not be the right solution.
So the
You may
checksum and the hash
retry
validation.
with the
Yeah.
same CDN.
Yeah.
That would be, but yes, you may have a fallback mechanism
All back
in
mechanism.
case even after multiple retries, you are still getting the corrupted file. Then it might happen that the CDN storage is corrupted rather than this is a network error. And in that case, you may fall back to another
Lower byte
CDN or
rate
any
streaming concept.
other
Yeah.
sources as well,
Yeah.
right? But now you see CDN is expensive. We had one functional requirement that it should be cost efficient. So how will you ensure that you are storing right files or less amount of data in the CDN?
So static assets I will be using on this point, so that cost efficiency is being maintained for this one.
Yeah, but would you put all the videos? Many videos are uploaded, but never they gets viewed by anyone.
Oh, yeah, so they will not be put, and I will be using a intelligent tiering also on this point, which might be shifting the video which are being less frequently used, and accordingly it will be shifting where the videos are less frequently used or they are being more frequently used.
Okay, okay,
Yeah.
sure. Uh, Now let's talk about the view counting of the video. So you have different chunks, you have no different redundancies, and viewers are watching it from all around the world. So how will you ensure your view count is always accurate and up to date?
So I will be using a dashboard on this point, which might be giving me the viewport and the latest statistics, which will be the data will be coming from a data warehouse as I mentioned before, and streaming and processing will be using through PySpark or Flask I can use.
Okay, okay,
On top of it, Kafka will be there for sure.
okay. So you will use the Spark. So how would be that calculation? Can you draw that also?
Okay.
Basically, the viewing part, we have covered only the upload part in the design. So
Yeah.
can you give the design for the viewing part? Capture all the discussion which we had.
I think it got stopped. Let me stop the screen and reshare it.
Sure. So in the meantime, let me update this to our viewers, all the points which we have discussed. And I see some comments as well. I got a comment from Pritish Anand saying that this is a very informative session.
It's working now.
Yes. So thank you, Pritish, for your kind words. Glad to hear that you are finding it useful session. So we covered adaptive bitrate.
And I say bitrate streaming is using Netflix also. Like users
Yes.
might have experienced when they shift to a lower bandwidth one.
Yes, in all the video players and video platforms, it's used perfect. Even in audio platform as well. So the discussions which we are doing is also applicable for design of all other types of streaming platform, which could include Spotify or which could also include Netflix and other OTT platforms like Geo Hotstar or now there are not too many, but yes, Hotstar or Sony Live. So all these discussions are valid for Geo Hotstar or Sony Live or Netflix as well. So we covered about error detection, uh, network error detection basically, and we also covered about client device detection. Okay. So whenever a user is viewing a video or is doing any action like likes or maybe anything like pause, you will capture that event to Kafka again.
This will be serving as an analytics pipeline, which might be recording status and everything for you.
Okay, okay. And then all these events will be processed by Spark, right? So you are saying
Yeah.
you will apply stream processing, and then they will do some calculation, and it will be uploaded.
Calculation for this in the data warehouse. You can use a number of queries for this and produce the results.
Okay, perfect. Then you will generate the report, and yeah, tell me what is a data warehouse?
So data warehouse is like, let's take example of Snowflake. Snowflake is a data warehouse.
Okay.
So yeah.
Okay, so you will use Snowflake for
Or any of the warehouse, whatever is like fruitful on this one.
Okay. Okay. Uh, and then, but yes, again, the cost will increase when you use some data warehouse like
Data warehouse, if we simply compare this to ECR, which is, or let's take example of Docker, it's a repository. Docker is storing images.
Yes.
So data warehouse, it's like central repository that stores large amount of data. So Snowflake is like just an example for this.
Yes. Okay. So with this stream, no, so now I have a problem here. A video may have say thousands of views within seconds of getting uploaded, right? So assume it's a video from some celebrity, and as soon as it's uploaded, immediately it start getting thousands or hundreds, millions of views also. So how would you ensure this is with low latency getting updated very fast.
The data is getting updated.
Yes. So likes, everything, should get updated immediately, and that can happen at very fast rate for global videos, right? So you have to consolidate all the information from so many CDNs you may be having, that okay, which is getting viewed.
So for this, like CDN network, like Cloudflare can be used on this point. User fetch the video chunks from the nearest location on this point should be used, and this will reduce the latency in the original node on the server also.
Okay, okay,
A
awesome.
partition query, like use a partition query by the like video ID on this point, or multiple consumer process events in parallel. We can run a mechanism.
Correct, correct.
Redis is already there to handle these type of like hundred of thousands of ops per second. So Redis we can use.
Yes, yes. So yeah, this has a good strategy that okay, you may use a counter, right? And based on the events, number of events on any particular video, you may update the counter.
Correct.
Also,
Redis will be used for the hot data, like as you mentioned, it will be thousands of likes and comment. So for this type of hot data, we can use Redis on this and
yeah,
publish the view to Kafka.
yeah, and also sometimes you don't have to be accurate, because
Yeah.
as you see in the YouTube, you may get say some numbers till 1,000, then you start seeing 1K, 2K, or 1.3K, like that, right? So M and all. So you should be close, may not be very real time. It's again all eventual consistency. So you may sync all these numbers from different sources at some rate. You don't have to keep immediately updating everything on real time. You may have a batch of all these events which could be processed maybe every second or every minute. Awesome. So these are all the use cases which we covered. Any other use cases you would like to highlight, Ankit?
We already covered the adaptive bitrate streaming, which is used in Netflix, and you also mentioned other audio platform also. Prime is also using this because I was watching some web series when I was traveling in train, so video quality dropped at that point of time. So adaptive bitrate streaming is there. That's the most important concept, and we also discussed about Redis. We also discussed the multi-part upload chunking and everything. So I think everything is covered, and we can check for any queries from the audience side also.
Yes. So one thing more is we can use the video compression as well. Various
Video,
video compression
like video,
algorithm.
yeah,
Uh,
video compression and can be used for this. Yeah,
yes.
decom is like a word for that. Video decom, video codec.
Yes. Coding and decoding, encoding.
Yeah.
So the compression algorithms they work is like if there is a dynamic scene, say for example, there is a movie scene, but the background is mostly static. So if say some actors are like having some conversation or any activities there, the background could be stored as an image. Only the actors may be kind of captured, their images could be captured, and their if they are moving, a car is moving or some object is moving, then there could be like initial and final destination which could be recorded, and it could be like reconstructed, the video could be reconstructed on the fly. So the disadvantage of compression and decompression is that it will require additional processing. It may lower the latency, and but yes, this is highly effective because it saves network cost, right? Network cost as well as the storage cost by multiple times. So in video and images, even in audio, you may get compression ratio of 10x as well, right? But in text, you also get sometimes 2x, 3x. But with video and images, you may get lot of compression, uh, maybe up to 10x and higher as well.
your video is lagging and we observe the live mechanism how YouTube works on video.
Yes.
It got
Yes.
lost. I think
Correct.
there was some network glitch. Yeah. We can check for any queries from the audience side also.
Yes. Let me see what else are there. Any queries or comments from the audience? So yeah, I don't see any queries except this comment from Pritesh Anand about that this is a very informative session. So thank you again. And if no other queries, then we can close this interview. But yes, we will also would like to announce that soon we will be starting mentoring program as well as cohort live classes for aspiring candidates who want to prepare and master system design, where we will be sharing our curriculum, which has been designed by experts and covers all the aspects of system design. And system design is a very complex topic. It covers various streams of information, starting from say operating system, databases, networking. So we will be covering everything in detail in a very structured format, in a way that it will be very easily understood and consumed. And we'll also provide guidance, which is one-on-one guidance about how to do well in system design interview, or how to act like an architect. So with our experience, with many years of experience in industries and in big companies, we can provide you insights like how these high scale systems are built, and we'll be sharing up more detail about it, and you could be the founding members or founding students of these batches. So I'll share about these details in coming few days, not weeks, in few days. uh, So, any queries, or if you have any other topics in mind which you would like us to make a video, so do share in the comments. I have seen some requests from our viewers about videos on generative AI, on some topics like hallucination. Also, I have received a request from our audience to cover topics like low level design. So, we will be uh, taking all these requests, and then we will prioritize them based on the preferences or our audience need asking. So if you have understood this, share some positive likes or comments to this video so that this can reach more audience, and subscribe to our channel so that we also get encouraged and we can build more such videos. So thank you. With this, we will close the session. So have a nice day ahead.